Welcome to the Diamond Elements series by Mastel. In this series, we hope to assist our clients in making more informed scalpel purchases. We aim to promote the understanding of blade design in relation to wound architecture and to encourage customers to purchase lances in place of spears. This presentation covers Element 3, Blade Margin Optimization. In Diamond Element 1, we compared three differently dimensioned piercing tips using vector mathematics. We showed that by reducing the tip angle from 90 degrees to 60 degrees, we could decrease the piercing-induced stress on the cornea by 50%. In Element 2, we covered alpha angles. An alpha angle is the included angle between two facet planes. In the example shown in this slide, facet plane 1 meets facet plane 2 to form an edge with a 45-degree alpha angle. Knowing the measure of the alpha angle at any diamond edge helps in distinguishing whether the edge is cutting or blunt. Any angle less than or equal to 110 degrees is a cutting angle, and any angle greater than 110 degrees is blunt. In Element 3, we will discuss blade margin optimization for dedicated width blades. We will then consider the characteristics of a dedicated width paracentesis blade. After that, we delve into optimizing side edge margins to improve wound architecture and subsequent wound closure. This brings us to our first discussion point, the characteristics of dedicated width paracentesis blades. Standard economy blades actually taper in along the side edges. However, a better option for a dedicated width paracentesis blade is one with parallel edges. These parallel edges enable the blade to be rehoned without losing dimensional integrity. In addition, the side edges on a dedicated width blade should be blunt so as not to enlarge the wound. Let's now discuss how to further optimize these long side edges. To do so, let's revisit the 90-degree angle. Because a 90-degree angle can be defined as a cutting angle, less than 110 degrees, these edges cut at the wound margins, creating box-shaped incisions. This leads to wound leaks and a higher risk of infection. When looking from the front view perspective, the colored lines represent a stress field around the diamond scalpel as it cuts through corneal tissue. As you can see, there is more stress near the corners as the smooth flow lines are interrupted. So, how do we improve these unintended cutting edges? We improve them with safety bevel faceting. When you add a safety bevel facet, you basically break the corners. By doing so, a 90-degree edge turns into a chamfer with 135-degree edges. As you can see in this displacement diagram, the lines now bend more smoothly over the corners. However, we can optimize even further. If we extend the bevels, we debulk the blade margins further. But we must retain the flat side at the margin to prevent forming a sharp edge. As you can see in this stress field, this yields a further reduction in corneal stress. Now that we have optimized the blade margins, we can look into creating asymmetric faceting. When looking at a diamond from the front view, asymmetric faceting shifts the center line of the blade. Rather than having 50% of the blade above the center line and 50% below, we'll instead have 80% of the blade above the center line and 20% below. This creates a thicker tunnel ceiling, causing the blade to dive more smoothly into the eye while still maintaining debulked margins. This is mainly featured on Mastel stealth faceted blades. One other special feature Mastel does to optimize the blade wound margins is sharp enhancement edges. Sharp enhancement edges feature a cutting edge near the tip that transitions to a safety bevel towards the end of the blade. The sharp enhancement allows you to clean up your wound margins near the tip, while the safety bevel prevents lateral expansion of the wound. As you can see, this is the latest in blade optimization technology. Stealth faceting reduces stress, cleans and protects wound margins, and dives smoothly by increasing the tunnel roof. In conclusion, blade margins directly impact wound closure. To optimize for wound closure, we first remove any unintended cutting edges that cause unnecessary corneal stress. We do this by breaking the 90-degree edges. To reduce stress further and to debulk the margins, we elongate our bevels. Next, we use asymmetric faceting to help the blade dive more smoothly and to create a thicker tunnel sealing on our incisions. And finally, sharp enhancement edges help create clean wound margins while also eliminating margin stress. This concludes Diamond Element 3. In Diamond Element 4, we will discuss blade thickness.